this video, we'll be looking at how to create graphs from quantitative data. So the setup here is doing some data wrangling on my data set of survey. I'm not going to go through all this. If you want to know more, go watch the video on data wrangling. I'm just going to go ahead and run it. And notice I now have survey over here in my global environment. I'm going to move down and I can actually just come here and use my outline to move to chapter 2 and section 2.2 quantitative data. We're going to look at histograms and density plots. We're going to make a histogram of a quantitative variable and state any findings you can see from the graph. If I click on the little arrow here next to it, I can see what my variables are. And I can see that I have some character ones, some numbers, characters, and numbers. So what might be interesting is to pick a variable from this list that is a quantitative variable. I see I have distance from campus, rent, height, and tattoos as all numerical ones. Maybe we can look at a histogram of distance. So I'm going to go ahead and insert an R chunk. And then again, the way the commands work in the mosaic package is they all start off with a command. In this case, we're doing a graph function, so GF for graph function, underscore, and then I want a histogram. So if I start typing histogram, I'll see histogram comes up in my list, and I can just hit tab, and it'll put it in there for me. All of these start with your response variable, tilde, your explanatory variable. Histograms don't have response variables, so there's no response variable. You can think of it as there's a space there, and then put in a tilde for is related to, and then put in your explanatory variable. In this case, my explanatory variable, I'm going to pick distance. And then I need to tell it what data set I'm working with, because there's lots of data sets I could have. In this case, I only have the one, but I still have to tell it which data set it is. I'm going to do data equals, and then survey is the name of my data set. And then I'm going to go ahead and graph this and see what it looks like. So here's what it looks like. I do want to say any findings I can see from this. But before I do that, I'd like to get a little bit more prettiness of the graph. So this just gets you the basic graph, but now we're going to pretty it up a little bit. We're going to put a title. Title is just title. Again, you can start typing it, then you hit tab and it'll fill it in for you. Quotes, you need to put quotes around to say what you want that title to be. And this is the distance students live from the CCC Lone Tree campus. And you can type anything you want for the titles, but you want something that makes sense for your reader, so your reader understands what is happening with it. Then I'm going to put in maybe a label for my axes. So instead of just distance, I might do X label, because that's the X axis, so X lab. And I might put in distance, and then this would have been in miles. And then I might want to do on the vertical axis, I might want to put in a label, and that's the y-axis, so it's y lab for y label. And I might put in number of students. And then I might want to have a color. Again, color will just like with quantitative, with categorical data, it just outlines it. So fill will actually fill in the bars. And you can pick any color you want. Let's say green this time. And there's my nice histogram showing what it is. Very nicely done. Story-wise, I can see that most students live within 10 miles of campus. This is 20 miles, this is 10 miles. So most students live within 10 miles of campus. There is somebody who lives more than 60 miles from campus, so I can see there's a big space here. There's a space here, and then there's a giant space here. So that tells me that there's some gaps in our data. People don't live in certain places and certain distances. This one's probably considered an outlier. And this graph is what we call skewed right, because it's going to have a really long tail on this side and everybody's over here. I like to now do a density plot. So again, I put in the returns just to give myself some reading room, just to make it more readable. Insert an R chunk. GF, I want a density graph. So GF for graph function and then density, and you can just start typing density. It will come up. You can arrow over, arrow down, and then hit tab, and it'll put it in there for you. But everything else is exactly the same. I want all of this information, exactly what I did, so I can just come up here, copy it. I'll have to retype, paste it in, and then I can run my density graph. The density graph is just a smoothed off histogram. There's a little bit more to it than that, but that's basically what it is. So what I can see is there's an awful lot of people that live within, or a lot of students that live within 10 miles of campus. Then we have another small peak here, and then we drop off, and then we have our outlier. So what this is showing me is this is the bulk of our students, same as in the histogram. The bulk of my students live within 10 miles of campus. Because there's a lot of people here. You can think of this as a dot plot. Each one of these things here is a dot. Kind of think of it as filling in those dots, and then we just kind of smoothed it off a little bit. And this one's really smoothed off. You can really see the nice shape of your skewness here, skewed right. I can actually graph two density plots on the same graph. So maybe I might want to do a graph of, again, GF, and I'm going to go ahead and just type in the one I just did. So I'm going to do the same one that I just did, this density graph. And then what I want to do is I want to do the same thing. So there's a piping symbol, which is the vertical line and the greater than symbol. You can also use another one, which is percent greater than percent. Both of them work. I don't care which one you use, whichever one you prefer to using. I'm going to use the vertical line and the greater than symbol this time. And then I'm going to do the exact same thing, but this time I'm going to do a GF graph, density graph of, let's say I did, and I don't know if I want to do rent because rents are huge, but maybe height because, actually, let's do tattoos. I don't know why I'd want to do this, but I'm just trying to get something where you can see what's happening. So I'm going to put that one on there, and I'll do tilde again, tattoo. I still have to tell it my data is in survey. I can actually change my title here instead of being distance. This is just, I can put distance and tattoos of students. And maybe not have all this other information about the Lone Tree campus. And then maybe I would want to do distance on my XLab and maybe distance and number of tattoos. All right. And then I can run this. Oh, I probably should do this a different color because now my problem is that I don't see much difference here. So maybe I'll put in a new color. I'll do a fill of, let's say, I don't want to use blue because blue and green look a lot alike to each other. I don't want to use red because red and green, people who are colorblind can't see them. So maybe I'll do um, um, let's go I'm bad at colors, so purple. And see what that one looks like. And then you can see that information. And then you get a little bit of idea of what's happening. Obviously, we have a lot of people that are 0 tattoos and then not much different. Again, you wouldn't really be interested in this one, but it just gives you an idea of what's happening. We can also facet based on our density on a variable, on a quantitative variable or categorical variable. I'm sorry, not quantitative, a categorical or qualitative variable. and I can add in a facet. So let's say I would like to look at rent based off of job. So GF underscore density. I like density plots better because I like the smoothness of them. I'm gonna tilde it based off of I'm gonna do rent. And then there's several different ways I can facet this. I can put that vertical line here and then put in job, data equals survey. And then again, I should have a title. And this might be rent faceted by job. And then maybe I want to do an X lab is equal to rent in dollars. And then maybe I want to do, I don't necessarily need to do the Y lab, but maybe I want to do a fill just because I don't particularly like the black ones by themselves. I like different fills. So I'm going to do lavender. If I spelled lavender right. Oh, I don't like lavender. You can't really see lavender. So let's pick a different color than lavender. Let's pick sea green. Oh, didn't like sea green. Probably needs that. I like sea green. All right, let's try just green. There are lots of colors, like I said, I'm just not good at that. And now you can see it shows you the no's and the yeses and where they are. And you can see that they both are about the same center of $1,000 a month. So I'm wondering how the no people can afford that. And so there's one way to facet. There's another way to facet also. So I'm going to copy this same thing. I'll create a new art chunk. So insert a new art chunk. I'll do this again, but instead of putting the vertical line in the job, and instead of putting the fill of color green, I'm going to fill based off of job. And then I can see them kind of on top of each other, gives me a little bit more information, shows me kind of what's happening. I find this very interesting because the no group seems to actually have some higher things than the upper group. There is somebody who pays an awful lot in rent. Most people are around the same amount of paying in rent. We can also filter based on a categorical variable. So let's say I actually wanted to filter based off of majors. So let's say I want to know how our nursing students are doing and just look at those students only. So I might create a data set called nursing. And so I'm giving it a name. The arrow says everything that follows is going to be assigned to that data set called nursing. I'm then going to use my survey data set. And then, so again, you heard me say the word and then, so that tells me to put in that piping symbol of the vertical line. And then I want to filter. And I'm going to filter major. That's my variable is equal to equal. I want it equal because I want to say I want it exactly equal to that. I don't want it greater than, I don't want less than, I don't want it not equal to that. And I'm going to put in nursing. And notice nursing seems to be capital. So I'll make sure I put it as a capital. Then I can run it and it looks like nothing happened, but I now look over here and I actually have a data set now over here, a new data frame called nursing, has 6 observations and 11 variables. If, by the way, you had typed this as lowercase nursing and tried to run it, it would run, but now you notice there are 0 observations in there instead of the number we had before. So that tells you something's wrong. Go look at it. Most likely it's that you didn't capitalize it. And now I see my 6 observations. If instead of looking at nursing, I would like to look at those who are not nursing. So maybe I'll say no, not nurse. And then again, I'm going to assign this so that that arrow assigns it to this. I'm going to use survey. Oops, I need to have my piping symbol. And then filter. And I'm going to do major, but this time I want to not equal, and the not is the exclamation point. So not equal nursing. And then I run that. And again, I have a new data set called not nursing. It has 39 observations. The 6 observations of nursing gets me my 45 that were in my original one. And that's how we do some quantitative data.